Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for grade 11 students in Functions and Relations working on the year-end summative. This is question 14.
It says Jennifer grew a colony of bacteria for a science project. On Monday morning, she found that the bacteria covered an area of 100 square centimeters on the gelatin plate. 12 hours later, she found that the area had increased to 200 square centimeters. Assuming that the growth rate was exponential, determine a function that models the growth. So I'm going to do the most basic thing I can in question A, which is to just assume that we doubled, which we did, in 12 hours. That's exactly what we did. So I'm not going to do anything fancy. I'm going to use A to represent the area that the bacteria cover. So the area is based on the original area, and we know that it doubled. So if you want, I could say this, 1 plus 1. So the original plus another group, so that's going to end up being a doubling time of 2. And then in terms of the exponent, because it doubled in 12 hours, I'm going to do this and say that 12 is the doubling period, and t would therefore be in hours. So let's clean this up a little bit. Um, so in this case, we know that we had a 100 gram starting, sorry, a 100 square centimeter starting amount. It was a doubling time, so t over 12. And we need to say that because this is my function, I need to say that A is the area in square centimeters, and T is time in hours. And there we go. So that's question A. So again, it doubled in 12 hours. I started with 100 square centimeters. Now question B says, what is the hourly rate? So I'm going to change this up a little bit. And so let's look at question B, which is I'm going to now assume that instead of doubling in 12 hours, I'm going to assume that there's some sort of hourly rate. So I'm going to rewrite this equation and assume that every hour it increases by a certain percent. So in part A, I just went with the simplest, most straightforward idea, which is in 12 hours it doubles. Boom, easy, done. But now if I want an hourly rate, now I have to consider that I have a certain percentage increase every hour. And I have to find by what percentage it increases. So this is how I've set it up. I started at 100. It ended up at 200. I don't know what the rate is, but I know it sat there for 12 hours. So now I'm going to have to try to solve for r in this equation. So the first thing I need to do is I'm going to divide both sides by 100. Okay, and now I need to get rid of exponent 12. So how do you get rid of an exponent? So let's make sure that you see this. If I have x squared, the opposite is square root. If I have x cubed, the opposite is cubed root. If I have x4, the opposite is fourth root, and so on. So to get rid of exponent 12, I need to take the 12th root. So this is the 12th root. So just in my calculator, I'm going to do this. I'm going to press 12, and then I have a button that looks like this. It says x, like this. So that's how I'm typing this into my calculator. Just a little side note in case you're not that comfortable with your calculator. So the 12th root of 2 is about 1.06. And now I know that r is 0.06, which is a 6% growth rate. So every hour, the area grew by 6%. Okay, I hope that was helpful. Boy, that might be my shortest video yet. I hope that was helpful. See you in the next video. Bye-bye.